Hello, this is Professor Gibson. Welcome to a lecture on section 9.2, linear regression for our Introduction to Stats class. Okay, so in 9.1 we talked about correlation and we talked about how to tell if there's a relationship and the measurement of it, the R, which is the correlation coefficient for the sample, the rho, the correlation coefficient for the um, population. Now we're going to talk about we've got our data, right? Our data points, and the points are scattered, and we, what is the very best line that we could draw that matches up with the points? Okay, so officially it's called a regression line, and the very best one is the one that, see, we've got all our data values here, right? And you draw the line through it, and the way the math works out, what it is it the one that has the minimum distance, so you square them, okay? So to get rid of the negative values, so the negatives don't cancel. So the line that if you take the distance from each point to the line and square it, and then add them all up, you get the smallest number, okay? So it's straight fit squared distances. Now, these distances are called residuals, okay? And they can be positive if the point's above the line, negative if it's below, and if the point is actually right on the line, then the residual zero. Okay? So, how do we do this? Well, it's an algebra thing. It's something of a mess. It's actually not really, compared to the R, the correlation, it's not, well, I guess it probably is about the same. Here's the formulas, right? If you're thinking in terms of a line, the hat means the predicted value. So the predicted value equals, or the value actually on the line, is mx plus b, right? Just your slope formula. Here's the thing for the m with all your x's and y's. It's an obvious mess. And here's the b. It's not quite as big of a mess, but it's pushing it, and it uses the m, actually. Um, anyway, yeah, so here it uses the m. Okay, so again, as we've done with many things, we're not actually going to calculate it by hand. You can calculate this either in Excel or on your calculator. It's, again, like the correlation. This whole chapter 9 is just much easier in Excel. All right. So what we're mainly going to do here, to recap, we're going to be given data points. We're going to be looking for the line that does the best job. The straight line does the best job of fitting that data. Okay. It's called a regression line. And we can do it on a calculator or on in Excel. To do it on the calculator, it actually says, if you in the calculator call it ax plus b instead of mx. But anyway, so you do stat and enter, and you have to enter all your data. All right, enter your x's in L1 usually, and your y's in L2, right? So you hit stat and then enter, and you've got L1, and you put all your x values in here, and you've got L2, you put all your y values in here. Once you got them all in, stat, calc, lin reg. The default is L1 and L2, so as long as you use the default, you don't actually have to select your list. If you put them in something else, you got to type it in here with a comma between them. Okay, then enter. And it'll tell you right on the same screen. This is the very same screen where we found the R and the R squared. You'll find it also has, at the top, it has y equals ax plus b, and it'll tell you the a, and it'll tell you the b. Okay, so you do have to individually type all the points in. All right, that's really that's the main difference between Excel and the calculator, is that since MyLabs Plus is going to let us just download the stuff to Excel, you don't have to individually type the points in. Now, if you use an Excel, it's the same. Y equals mx plus b is our slope-intercept form. The command to find the slope is equal slope, highlight the y's, then highlight the x's. The command to find the b, the y-intercept, is just intercept, highlight the y's, highlight the x's. Okay, so let's look at one here. By the way, let's talk one other thing here. Let's look at this question. Given a set of data and a corresponding regression line, describe all values of x that provide meaningful predictions for y. So what's going to happen, or what they're getting at here, is you're going to be given some data values, right? And you're going to be given some x's and some y's. So let's just say the smallest x is 30, and you got a bunch of other ones, and the biggest one is 75. Okay? And then it'll give you all the data values matching those up. So describe all values of x that provide meaningful predictions for y. Well, normally what people do is they'll only use data to make a projection for the other variable if it's close, like maybe like if since the data ended at 75, maybe they go to 80 or something. So it's a judgment call. But our book is very conservative. So if the x values went from 30 to 75, it's only going to go from 30 to 75. So what this is what it wants. Prediction values are meaningful only for x values in or close to the range of the original data. In reality, it's going to say in. All right. Every question it answers on MyLabs Plus, if it's outside the range of the original x values, then it's going to say no, you can't do that. Okay. It's just very conservative. Okay. So now let's look at a standard question on MyLabs Plus. So find the equation of the regression line for the given data, then construct a scatter plot of the data and draw the regression line. The pair of variables have a significant correlation. Okay, in other words, we're going to say, look, we're going to assume we've already looked into it. We know there's a significant correlation. Now we're going to try to find the line, the equation of the line. Okay, so again, here's the thing. If we were in MyLabs Plus, if you left click on that, you can load that into MyLabs Plus. Okay, so kind of pretend we got to click it. I put these values into Excel. Okay, so we're going to have to find the regression line. So I blew this up a little bit to make it easier to watch. Okay, so we need the slope and the y-intercept in order to put it in slope-intercept form, right? So equals slope, open parenthesis, highlight the y values, comma, highlight the x values, close parenthesis. There's our slope. We want the y-intercept, so the command is intercept. Highlight the y's, comma, highlight the x's, close parenthesis, enter. So 0.5188, and then a perfect 39, right? 0.5188, 39. Again, if you wanted to do this, right, you want to do this in your calculator, what you have to do is you hit the stat key, then hit enter. Okay, this will bring up the screen with the variables L1, L2, right, etc. Put the x's in L1, type the x's into L1, type the y's into L2, and then do this what I set up here, right? Once they're all in, stat, calc, linreg, enter. If you put the x's in L1 and the y's in L2, you won't have to select your lists, okay? You may, and depending on your calculator, you may have to hit enter. Which exact model you have, you may actually have to hit enter a couple of times. All right, so either way you cut it, we have our regression equation now. They'll ask you to graph it. Now, you can tell this just is partial paying attention to details, partial just basic. So our slope here is positive, right? So that tells you right now, these are the two that are going up. It's one of these two. And then I just match points. So you'll notice, so we're studying, sometimes the scales are off 0 to 8. 0 to 8, well, that works fine for the actual data. 0 to 80 for the y's, yes, that's okay. So now you got to look at individual values. Like here, there was an actual 0 with a 39. Well, this one, there's no data value with 0. You see that? The first one's at 1. Here's a 0 that looks fine for 39. there's the answer. Right? You never know which one it's going to be. It's just about following the details. A lot of times, if you check the slope being positive or negative, you can throw away at least one of them. This time, we could throw out two of them. Now, the next step. They're going to give you 3 or 4 of these in each one, typically, and they're going to ask you to predict the value of y for a certain x. So this one says predict the value of y for x equals 2. So what you literally do is you just plug this into your calculator. All right. So here's our equation, right? 5.188x plus 39. So 5.188, this says x equals 2, times 2 plus the 39, and this will be the 49.4, right? Now, notice that our x values go from 0 to 5, and if you're entering them in, they tend to do this more like real data. They're not going to be perfect. You're not going to get 1, 2, 3, 4, 5. Like in this one, you see there's 2 5s, right? It doesn't go, they scramble things up just a little bit. Real data tends to do that. All right, so B for y equals 3.5. Well, it's the same thing. We still got the same equation. Put it in your calculator, 5.188 times 3.5 now, because that's where the x is, plus 39. We get this one. Now, it has 2 more here. I'm only going to do the C. Notice this one, x equals 15. Okay. Well, the x's actually go from 0 to 5. So 15 is outside the range. So the answer is you can't make it. There's no meaningful projection. This last one, x is 4.5. It's the same thing as you did for the others. 5.188 times x of 4.5 plus the 39. Put that in your calculator. That won't come. Okay, so this is the most common one that we see. A lot of them are like this. There's questions about residuals and other stuff, but I think that's enough to get you going strong on this section. I hope you found this helpful.